The national animal of Canada, the beaver. Canada's choice of the beaver as its national animal reflects a deep connection between the nation's identity and one of nature's most industrious creatures. The North American beaver, Castor canadensis, has been officially recognized as Canada's national animal since 1975, but its significance to Canadian history, culture, and ecology extends far beyond any formal designation. This remarkable rodent has shaped the country's development, influenced its economy, and continues to play a crucial role in maintaining the health of Canadian ecosystems. Historical significance and the fur trade. The beaver's prominence in Canadian history cannot be overstated. Long before European colonization, indigenous peoples across North America had developed sophisticated relationships with beavers, utilizing their pelts for warmth, their meat for sustenance, and their engineering prowess to understand water management. The beaver held spiritual significance for many First Nations, often representing industriousness, family unity, and harmony with nature. The arrival of European explorers in the 16th and 17th centuries transformed the beaver from a respected wildlife neighbor into the foundation of a continental economy. The Hudson's Bay Company, established in 1670, built its entire business model around beaver pelts, which were in tremendous demand in Europe for making felt hats. The soft, dense underfur of beaver pelts possessed unique properties that made them ideal for creating waterproof, durable felt that became a symbol of European fashion and status. This demand for beaver pelts drove exploration and settlement patterns across what would become Canada. French voyageurs and coureurs de bois pushed deeper into the continental interior, establishing trade relationships with indigenous communities and mapping vast territories in pursuit of beaver-rich waterways. The competition between French and English traders over beaver territories contributed to numerous conflicts and ultimately influenced the geopolitical boundaries that would define modern Canada. The economic importance of beaver pelts was so significant that they essentially functioned as currency in many parts of early Canada. The Hudson's Bay Company established a standard unit of trade called made beaver, which became the baseline for valuing other goods and services. This system persisted for over 2 centuries, making the beaver arguably the most economically influential animal in Canadian history. Biological marvel. Understanding beaver physiology. The North American beaver is the largest rodent in North America and the second largest rodent globally, with adults typically weighing between 35 to 65 pounds, though some exceptional individuals can reach up to 85 pounds. Their robust build reflects their semi-aquatic lifestyle, with several remarkable adaptations that make them uniquely suited to their environment. Perhaps the most distinctive feature of beavers is their large, flat, scaly tail, which serves multiple crucial functions. This paddle-like appendage acts as a rudder for swimming, a prop when the beaver sits upright on land, and a communication device when slapped against the water's surface to warn other beavers of potential danger. The tail also serves as a fat storage organ, helping beavers survive harsh Canadian winters when food sources become scarce. Beavers possess specialized teeth that grow continuously throughout their lives. Their prominent orange incisors are not just for show. They contain iron, which makes them exceptionally hard and gives them their distinctive color. This iron content allows beaver teeth to maintain their sharp edge even after gnawing through countless trees. The self-sharpening design ensures that as the front surface wears down from use, the softer back portion wears away faster, maintaining a chisel-like cutting edge. Their dense fur coat consists of 2 distinct layers, long, coarse guard hairs that provide protection from debris and water, and a thick undercoat of fine fur that provides insulation. Beavers meticulously groom their fur with specialized split claws and apply waterproofing oil from their castor glands. This grooming behavior is essential for maintaining the insulating properties of their fur, as a poorly maintained coat could lead to hypothermia in Canada's cold waters. Beavers have adapted to aquatic life with several other remarkable features. They possess transparent eyelids that function like goggles underwater, allowing them to see while swimming. Their ears and nostrils can be sealed shut when diving, and they can hold their breath for up to 15 minutes while working underwater. Large, webbed hind feet make them excellent swimmers, while their smaller front paws are surprisingly dexterous for manipulating building materials. Ecosystem engineers. The beaver's environmental impact. Beavers are often called ecosystem engineers because their activities create and modify habitats that benefit numerous other species. Their dam building behavior is one of the most significant examples of animal engineering in the natural world, with impacts that ripple throughout entire watersheds. When beavers construct dams, they create wetland environments where none existed before. These artificial ponds serve multiple ecological functions, acting as breeding grounds for amphibians, nesting sites for waterfowl, and feeding areas for various mammals. The still waters behind beaver dams allow sediment to settle, improving water quality downstream and creating fertile conditions for plant growth. The wetlands created by beaver dams support remarkable biodiversity. Studies have shown that beaver ponds can support up to 85% more species than the surrounding forest. These habitats attract moose, deer, and smaller mammals that come to drink and feed on aquatic vegetation. Fish populations often thrive in beaver ponds, particularly species like brook trout that prefer the cooler, deeper waters that dams create. Birds are perhaps the most obvious beneficiaries of beaver activities. Great blue herons, belted kingfishers, and various species of ducks rely on beaver ponds for feeding and nesting. The dead trees that result from flooding, called snags, provide nesting cavities for woodpeckers, which in turn create homes for secondary cavity nesters like chickadees and nuthatches. Beaver dams also play crucial roles in water management and climate regulation. During periods of heavy rainfall or snowmelt, beaver ponds act as natural retention basins, reducing flood risks downstream. Conversely, during droughts, these reservoirs slowly release stored water, maintaining stream flow when it would otherwise cease entirely. This water regulation service is particularly valuable in Canada's variable climate, where extreme weather events are becoming increasingly common. The carbon sequestration potential of beaver wetlands has gained attention in recent climate change discussions. The waterlogged conditions in beaver ponds slow the decomposition of organic matter, effectively storing carbon that would otherwise be released into the atmosphere. Some researchers estimate that beaver wetlands store significantly more carbon per hectare than many other ecosystem types. Social structure and behavior. Beavers are highly social animals that live in family groups called colonies. A typical beaver colony consists of 2 adult parents, the current year's offspring called kits, and often the previous year's young yearlings. This family structure reflects strong social bonds and cooperative behavior that extends to all aspects of beaver life. The construction and maintenance of dams, lodges, and canals is a collaborative effort involving all capable family members. Adult beavers teach their offspring essential skills through direct demonstration and patient guidance. Young beavers learn to identify suitable building materials, understand the principles of water flow and dam construction, and develop the physical strength and coordination necessary for their engineering projects. Communication among beavers involves multiple sensory channels. They use scent marking extensively, depositing castoreum, a substance from their castor glands, and anal gland secretions on prominent landmarks to communicate territorial boundaries and individual identity. Vocal communications include soft whimpers between family members, loud wails from separated individuals, and various grunts and tooth chattering during social interactions. The famous tail-slapping behavior serves as an alarm system that can be heard and felt over considerable distances underwater. When one beaver detects danger and slaps its tail, the sound and vibration alert all beavers in the area to take cover. This early warning system is crucial for survival in environments with predators like wolves, bears, and lynx. Territorial behavior in beavers is complex and varies with population density and resource availability. While beaver families generally maintain exclusive territories along waterways, boundaries can shift seasonally and may involve complex negotiations between neighboring colonies. Territorial disputes occasionally occur, but beavers more commonly resolve conflicts through scent marking and avoidance behaviors rather than direct confrontation. Construction techniques and engineering prowess. Beaver engineering projects demonstrate remarkable sophistication and adaptability to local conditions. Their construction techniques vary depending on water flow rates, available materials, and topographical features, showing a level of environmental assessment and planning that rivals human engineering in its appropriateness to local conditions. Dam construction typically begins with the selection of an appropriate site, usually where the stream bed narrows or where natural features like boulders provide anchor points. Beavers start by anchoring large logs or branches to stream bottom, often wedging them against rocks or driving the heavy ends into substrate. They then weave smaller branches horizontally through these vertical supports, creating a lattice structure that can withstand considerable water pressure. The spaces between branches are filled with a mixture of mud, rocks, leaves, and other available materials. Beavers use their front paws to pack this material tightly, creating an increasingly watertight barrier. As water pressure builds behind the dam, it actually helps compact the fill material, making the structure more stable over time. Beaver lodges represent another marvel of animal architecture. These dome-shaped structures are built from the same materials as dams but serve entirely different functions. Lodges provide secure sleeping quarters, nurseries for young beavers, and food storage areas. The interior chambers are positioned above the water level but accessed through underwater tunnels, providing protection from land-based predators while allowing easy access to the water. The lodge's thick walls provide excellent insulation, maintaining comfortable temperatures even during harsh Canadian winters. Beavers continue to add material to their lodges throughout their occupancy, with some structures growing to impressive sizes over many years of use. The largest recorded beaver lodge measured over 12 feet high and 40 feet wide, representing decades of construction by successive generations of beavers. Canal construction demonstrates perhaps the most sophisticated aspect of beaver engineering. When preferred food sources are located away from main waterways, beavers dig channels to transport materials more efficiently. These canals can extend hundreds of meters from the main pond and include sophisticated water management features like small dams and locks that maintain water levels suitable for floating logs. Diet and foraging behavior. Beavers are strict herbivores with dietary preferences that change seasonally and influence their habitat modification activities. During spring and summer, beavers consume a diverse array of aquatic and terrestrial plants, including water lilies, pond weeds, grasses, and various herbaceous plants. This diverse diet provides the nutrients necessary for growth, reproduction, and the intensive physical labor of construction projects. The transition to autumn brings significant changes in beaver behavior as they prepare for winter survival. During this critical period, beavers focus intensively on harvesting and storing woody materials, particularly the inner bark cambium of trees like aspen, poplar, willow, and birch. The cambium layer contains the sugars and nutrients that trees transport between their roots and leaves, making an excellent source of carbohydrates and essential nutrients. Beavers demonstrate remarkable selectivity in their tree harvesting, showing preferences for certain species and age classes. Young, fast-growing trees are often preferred because their cambium is more tender and nutritious. Aspen and poplar are particular favorites across most of Canada, though regional variations exist based on local forest composition. The famous beaver tree cutting technique involves gnawing around the circumference of a tree trunk, creating the distinctive hourglass shape that leaves unmistakable evidence of beaver activity. Contrary to popular belief, beavers cannot actually control the direction a tree falls with any precision. They simply gnaw until the tree's structural integrity is compromised enough that gravity and wind complete the job. Once a tree is felled, beavers systematically process it by removing branches and cutting the trunk into manageable sections. These materials serve dual purposes: immediate consumption and construction materials for dams and lodges. During autumn, beavers create underwater food caches near their lodges, storing branches and small logs of mud where they remain fresh and accessible throughout the winter months when surface waters are frozen. Seasonal adaptations and winter survival. Canadian winters present extraordinary challenges for semi-aquatic mammals, but beavers have evolved remarkable adaptations that allow them to thrive in some of the harshest climates on Earth. Their winter survival strategy involves both physiological adaptations and sophisticated behavioral preparations that begin months before the first frost. As autumn temperatures begin to drop, beavers enter a period of intensive preparation activity. Their metabolic rate increases, and they build up fat reserves that will sustain them during the lean winter months. The thick fat layer also provides additional insulation against cold water temperatures. Their fur coat grows denser, with the undercoat becoming particularly thick to trap warm air close to their body. Beaver lodges play a crucial role in winter survival, functioning as insulated shelters that maintain temperatures well above freezing even when outside air temperatures drop to minus 40 degrees Celsius or lower. The mass of sticks, mud, and organic material that forms the lodge walls creates an effective thermal barrier, while the beaver's own body heat contributes to maintaining comfortable interior temperatures. The underwater entrance tunnels to beaver lodges typically remain ice-free throughout winter due to the flow of water and the thermal mass of the pond. This allows beavers to access their food caches and move between different areas of their territory, even when the surface is covered with thick ice. In extremely cold conditions, beavers may remain in their lodges for days at a time, conserving energy and avoiding exposure to harsh conditions. Winter food storage requires careful planning and execution. Beavers must harvest sufficient materials during autumn to sustain their entire family through months when fresh vegetation is unavailable. The underwater caches must be positioned in areas where they won't freeze solid and remain accessible through the underwater tunnel system. The store will continue to provide nutrition throughout winter, though its quality gradually decreases over time. Reproduction and life cycle. Beaver reproduction follows a seasonal pattern closely tied to Canada's climate cycles. Mating typically occurs during late winter, usually in January or February, when pairs strengthen their bond through increased grooming and sharing of sleeping spaces. The gestation period lasts approximately 100 to 110 days, with births occurring in late spring, when environmental conditions are most favorable for raising young. A typical beaver litter consists of 2 to 4 kits, though larger litters occasionally occur. Newborn beavers are remarkably well-developed compared to many other mammals, born with their eyes open, a full coat of fur, and the ability to swim within hours of birth. This precocial development is crucial for survival in an aquatic environment where mobility is essential from an early age. Mother beavers are extremely attentive parents, nursing their young for the first 6 to 8 weeks while gradually introducing them to solid foods. The entire family participates in kit care, with older siblings often helping to guide and protect their younger relatives. This cooperative breeding system strengthens family bonds and ensures that essential survival skills are passed down through generations. Young beavers remain with their parents for approximately 2 years, learning essential skills through observation and practice. During their first summer, kits focus on developing swimming abilities and learning to identify safe foods. Their second year involves more intensive training in construction techniques, territorial behavior, and the complex social interactions that characterize beaver society. Sexual maturity typically occurs around 2 years of age, coincided with a time when young beavers are encouraged to leave their family territory and establish their own colonies. This dispersal behavior is crucial for maintaining genetic diversity and colonizing new habitats. Young adult beavers may travel considerable distances in search of suitable unoccupied territories, sometimes covering tens of kilometers during their dispersal journeys. Conservation status and modern challenges. The beaver population in Canada has experienced dramatic fluctuations throughout recorded history, serving as an early example of both overexploitation and successful conservation management. By the early 20th century, intensive fur trapping had reduced beaver populations to critically low levels across much of their former range. Some regions that once supported thousands of beavers were left with no viable populations at all. Recognition of this decline led to some of Canada's earliest wildlife conservation efforts. Provincial governments began implementing trapping regulations, establishing closed seasons, and creating protected areas where beavers could recover without human interference. These early conservation programs were remarkably successful, demonstrating the resilience of beaver populations when given adequate protection and suitable habitat. Today, beaver populations across Canada are generally stable or increasing, with some regions supporting densities approaching historical levels. Current estimates suggest that Canada hosts between 6 and 12 million beavers, representing one of the world's most successful large-scale wildlife recovery programs. This recovery has allowed beavers to resume their ecological role as ecosystem engineers across vast areas of Canadian landscape. However, modern beaver populations face new challenges that differ significantly from the historical threat of overtrapping. Urban expansion and agricultural development have eliminated beaver habitat in many areas, particularly in southern Canada, where human population density is highest. Road construction creates barriers to beaver movement and increases mortality from vehicle strikes during dispersal periods. Climate change presents complex challenges for beaver populations. While warming temperatures may extend the growing season for preferred food plants, they also increase the frequency of extreme weather events that can damage beaver infrastructure. Changes in precipitation patterns affect water levels in beaver ponds, potentially making some territories unsuitable for long-term occupancy. The relationship between beavers and human infrastructure remains complicated. While their ecological benefits are widely recognized, beaver activities can conflict with human land use objectives. Beaver dams occasionally flood roads, agricultural fields, or residential areas, leading to management conflicts that require careful balancing of ecological and human needs. Cultural impact and symbolism. The beaver's role as Canada's national animal extends far beyond biological or historical significance into the realm of cultural identity and national symbolism. The beaver appears on Canadian currency, stamps, and official emblems, serving as an instantly recognizable symbol of Canadian values and character traits. The beaver's reputation for industriousness, cooperation, and environmental stewardship resonates strongly with Canadian cultural values. The image of beavers working together to build and maintain their communities reflects ideals of collective effort and social responsibility that many Canadians see as fundamental to their national character. The beaver's ability to thrive in harsh northern environments mirrors Canada's own identity as a northern nation that has learned to prosper despite challenging climatic conditions. Indigenous cultural traditions continue to honor the beaver's significance through stories, art, and spiritual practices. Many First Nations view the beaver as a teacher whose behaviors offer lessons about family cooperation, resource management, and living in harmony with natural cycles. These traditional perspectives have gained renewed relevance as Canadian society grapples with questions about sustainable development and environmental stewardship. The beaver's influence extends into Canadian literature, art, and popular culture, where it often represents authentic Canadian identity as distinct from other national symbols. Unlike imported symbols that might be found in other countries, the beaver is uniquely North American and intimately connected to the Canadian landscape and experience. Future prospects and research. Contemporary beaver research in Canada focuses on understanding how these remarkable animals might contribute to addressing modern environmental challenges. Scientists are investigating the potential for beaver activities to help mitigate climate change impacts, restore degraded watersheds, and maintain biodiversity in human-modified landscapes. Research into beaver wetlands carbon sequestration potential has yielded promising results, suggesting that encouraging beaver colonization of appropriate areas could contribute to Canada's climate change mitigation efforts. Studies are ongoing to quantify these benefits and identify strategies for maximizing the climate benefits of beaver activities while minimizing conflicts with human land use. The role of beavers in water management has gained renewed attention as Canada faces increasing variability in precipitation patterns and more frequent extreme weather events. Beaver dams' natural flood control and water retention capabilities could provide cost-effective alternatives to expensive engineered solutions in some watersheds. Genetic research is providing new insights into beaver population structure, migration patterns, and adaptation to different environmental conditions across Canada's diverse landscapes. This information is crucial for developing effective conservation strategies and understanding how beaver populations might respond to future environmental changes. Educational programs increasingly emphasize the beaver's ecological importance and its role in Canadian identity, helping new generations understand and appreciate this remarkable species. These efforts are essential for maintaining public support for beaver conservation and fostering coexistence between beavers and human communities. Conclusion: the North American beaver stands as a fitting symbol for Canada, embodying the industriousness, adaptability, and environmental awareness that characterize the nation itself. From its crucial role in Canada's economic development to its ongoing importance as an ecosystem engineer, the beaver represents the intricate connections between human society and the natural world. As Canada faces the challenges of the 21st century, including climate change, biodiversity loss, and sustainable development, the beaver offers both inspiration and practical solutions. Its engineering prowess demonstrates that working with natural processes can be more effective than fighting against them, while cooperative social structure provides a model for addressing complex problems through collective effort. The continued success of beaver populations across Canada represents a conservation victory that offers hope for other species and ecosystems facing modern challenges. By understanding and supporting the beaver's ecological role, Canadians can help ensure that their national animal continues to shape the landscape and inspire future generations. The beaver story is ultimately Canada's story, a tale of adaptation, perseverance, and a profound connection between human culture and the natural world. As both a national symbol and an ecological keystone species, the beaver embodies the possibility of a future where human societies and natural ecosystems thrive together, creating something greater than either could achieve alone.